Good afternoon everybody, myself Acharya Vishvendra, and today I'll discuss a worksheet on the topic of electric flux. So the first thing is flux through an open surface when electric field and area vector are constant for the plane surface is E dot S, which is Es cos theta. Here E is the electric field, S is the area vector, and theta is angle between area vector and electric field as shown over here. So from here if we draw the graphical variation of theta, so that will be a cosine curve, maximum at 0 and minimum at 90. And it should be noted that it's the magnitude of the flux which is concerned for various calculations and analysis. So it is maximum when theta is 0 and phi max is Es, and minimum is theta is 90 and mod phi minimum is 0. So it should be noted that we consider the magnitude of flux only for comparison, because only magnitude is relevant in comparison. That is the point over here. Next is through an open surface, if electric field is variable or area vector is variable, we use integration of A dot ds to calculate the net flux. Next is if electric field is given in vector form as E1i E2j E3k, area vector is also given in vector form like S1i S2j S3k, then E dot s is E1 S1 plus E2 S2 plus E3 S3. Then we have flux through a closed surface as surface integral of E dot ds, which is also equals to Q enclosed by epsilon naught, and it is also called as the Gauss law. Now we have an interesting case of a cube. Suppose a cube 1, 2, 3, 4, 5, 6, 7 it is placed, and there is a charge q. So corresponding to different positions we have different cases of flux. So the first question is, if charge is placed at the center, then the net flux through the cube will be q by epsilon naught. And if in that case a flux through a single face is to be calculated, it will be q by 6 epsilon naught. Now if q is at the corner, then total flux through the cube will be q by 8 epsilon naught. And if q is at the corner 1, so if it is at the corner 1, so if we take a plane which includes 1, just like 1 2 3 4, so electric field will be in the plane and area vector of that plane will be perpendicular to the plane. So the flux through the plane which contains 1 will be 0. So because of that flux through 1 2 3 4 or 1 2 7 8 or 1 4 5 8 will be 0, and rest of the flux q by 8 epsilon naught will be divided equally into the three parts. The flux through the three other faces, that is 2 3 6 7 3 4 5 6 or 5 6 7 8 will be q by 24 epsilon naught. Now there is an interesting question. If q is at the edge, then we have the total flux through the cube as q by 4 epsilon naught. There is one important question. Suppose the charge q is placed at a distance of x from a disk of radius r, then the total flux through the cube is given by q by 2 epsilon naught 1 minus cos theta, where theta is this angle which is also called as semi-vertex angle of the cone. There is one important thing. Suppose a hemisphere is placed and a uniform electric field is over there, then flux through the left surface is E into pi r square by 2. This pi r square by 2 is the area of this half semicircle. So all the lines which passes through the left surface will eventually will be encountered by this plane area, and so magnitude will remain the same. But since these are entering inward and we take outward flux as positive, so that's why we use negative sign. So flux through the left curved surface will be minus e pi r square by 2. Similarly, for the right surface, it will be into pi r square by 2, because same lines will cross the right path, but in a opposite way. For the left part, it is inward; for the right part, outward, and the net flux will be 0. We have another interesting case that there is a sphere of radius r and electric field is like this. So flux through the left surface is minus e into pi r square. Flux through the right is also same, and net flux is 0. Suppose we place a cylinder over here, then if we try to look at it, there is a concept of projected area. So this will be the projected area, and all the field lines will enter through this. So through the left surface it will be minus e into 2 pi rh, from the right e into 2 pi rh, and net flux will be 0. Similarly, if we place a cone over here, then the projected area will form this triangle. So from the left it will be negative, and area of this particular triangle will be half into base 2r and altitude is h. So area will be rh. So flux through the left surface will be minus erh, through the right surface erh, and net flux will be 0. Then there is a concept that a dipole is placed inside a closed surface, so the net flux will be 0 over here. Then there is interesting application of closed surface. The flux through the closed surface is surface integration of E dot ds. Here important case is, suppose this is a surface, 2 charges are inside the surface and 3 are outside. So here this term electric field is due to all the charges from q1, q2, q3, q4, q5. But this q enclosed contains only charges inside the surface. The reason is can be simply derived that if we consider charges outside also, so suppose it enters through this surface area, then it will leave through this, so that flux will ultimately get cancelled out. So it is based on simple logical argument on that. Then we have another question. A charge q is placed at the apex of the cone, then flux through the curved surface will be zero, because here electric field will be along the curved surface, so it area vector will be perpendicular to that, and hence flux through curved surface will be zero. But flux through the base will be q by 2 epsilon naught into 1 minus cos theta, and the total flux will be q by 2 epsilon naught 1 minus cos theta. Now there is another interesting question. If we place the charge q at the base, then flux through the base will be zero, because of same reason, because here flux electric field will be in the plane and area vector will be perpendicular to the plane, so flux through the base is zero. Flux through the curved surface here will be q by 2 epsilon naught. So this argument can be derived from symmetry. Suppose I place another cube over here, so the q is enclosed within the two cones, so obviously through the half cone it will be q by 2 epsilon naught, and the total flux here will be q by 2 epsilon naught. So this was a brief discussion on the topic of electric flux. If you have any doubt, you can ask in the comment section. Thank you and have a nice day.